We are discussing the modeling of the transportation problem, and we stopped with the constraint that each fish processing factory should ship all the cases that it produces. And in the slides, on slide number 17, I showed you how this can be modeled as a mathematical constraint. Now let's see why this constraint is not enough. So we want to model each factory ships its total production. So in our example case we had 3 factories, F1, F2 and F3, and factory 1 had 45 cases production per day, factory 2 had 121 and factory 3 95 cases. And we had 4 customers, A, B, C, D. Customer 1 requiring 81 cases, customer 2 78 cases, customer C 47 cases each day, and finally customer D requires 55 cases per day. Then this constraint that each factory ships its total production has been modeled as follows. We had our decision variables. So if we ship from factory F1, first I model that we want to ship everything that is produced in factory F1. We have 4 decision variables because factory F1 can ship to A or to B or to C or to D or any combination thereof. So this would be modeled as follows. The decision variable for the delivery from factory 1 to B plus the value of the decision variable O. F1 to C plus XF1 to D, and this is everything that is delivered, that is going out of factory F1 towards the customers, and this needs to be equal to 45 because 45 cases are produced in factory F1 and everything needs to go outside of this factory. For X2 we follow the similar pattern. In F2 we produce 121 cases. So need to be very careful. And for X3 we produce 95 cases. So this is XF3 to A plus, just write it like this, F3D is 95. So let's assume we ship from F3 78 cases to B, then our decision variable F3 to B could have the value of 78, and then what is left in factory 3, 17 units. So let's say the remaining units from F3 are shipped to A, 17 units. Yeah. And the values of the other decision variables, F3, that represent this factory for C equals the same as for F3 to D equals 0. So then these 4 values of the decision variables would fulfill this constraint. Yeah. So that is nice, because now we make sure that these 95 units are flowing out of factory 3 to the mother factories. However, our model is still not complete. What might happen if we look at factory F1, at these constraints, factory 1, we might have the following values of decision variables: x f1 to b equals 45, just as an example, and the other decision variables related with factory f1 are 0. Then we would fulfill this constraint. Nice. This would be done. Okay, nice. But now, what is the problem? What is the problem of this solution? We fulfill the first constraint. We would fulfill the constraint number 3. However, if we look at what is arriving at our customer B, we already have 78 units from factory 3 and an additional 45 units from factory 1. Though in total we have 133 units, and this is way too much. We get too many products at customer B. Therefore, these types of constraints are not enough to describe our mathematical model. We need to add additional constraints.